Lesson 8.1, conic sections and a new look at parabolas. To start this lesson, we're going to talk about some different shapes that can be created with different cross sections. And then we're going to take an in-depth look at parabolas. We've talked about parabolas in the past, but now we're going to look at different ways to write the equations for parabolas with some new information. Now we're going to discuss a right circular cone. You don't have to write this down. We're just going to use this next when we talk about cross sections. So we have two parts to this cone. We have the upper nap and the lower nap. Where these two naps intersect, that's called the vertex. We have this line that goes across the upper nap and the lower nap through the vertex. And that line, if we would rotate it about this vertex, that's where we get this circular motion. That line is called the generator. And then we also have what's called the axis. That's our vertical line that goes through the vertex and then in between the center of the lower and upper naps. Now we're going to take a look at some different shapes that are created by cross sections of the upper nap and lower nap. You don't necessarily have to write these down. Just recognize these shapes as we go through them. So if we create a cross section through either the upper nap or the lower nap, one of those, at an angle, we can see that we're going to have an ellipse that is formed from that cross section. If this would have been perpendicular to the axis, then we would have had a circle that was created. If we make a cross section through the upper nap or the lower nap, this would apply as well, such that we go through the base, then this is going to create a parabola. We can see that U shape that's formed. If we make a vertical cross section that intersects both the upper nap and the lower nap, now we have what's called a hyperbola. It's very similar to the shape of a parabola, but now we have two separate parts. We have some other parts we can talk about when these cross sections are created. If our cross section, our slice, goes perpendicular to the axis right through the vertex, then we have a single point that is going to be formed. If we have a slice that goes through the edge of the upper nap and the lower nap, then we just have a single line that is formed. The line is the generator that we talked about at the beginning. And then if we make a slice that goes through the axis so that it intersects basically two generators, then we just have two intersecting lines that are formed. Now we're going to talk about the formal definition of a parabola. This is something I expect you to know. So a parabola is a set of all points in a plane equidistant from the directrix and the focus. Okay, so I expect you to know that formal definition. Now we're going to talk about what the directrix and the focus are, relating them to the parabola. So we have our U-shaped parabola that we're familiar with from the past. We have our vertex, which we know is going to be the minimum or maximum point for the graph. The focus is going to be a point that lies within our parabola, and the directrix is going to be a line on the opposite side of the focus. The distance from the vertex to the focus is going to be equal to the distance from the vertex to the directrix. What this definition is telling us is that if we pick any point on the parabola, the example they have is right here, the distance from this point to the focus is going to be equivalent or equal to the distance from this point to the directrix. And that would work for any point I pick along the parabola. If I pick a point here, the distance from the focus to this point is going to be equal to the distance from this point to the directrix. Next, we're going to go through some graphs relating some of the information, talk about the focus and the directrix and the graph of the parabola. I wouldn't write this stuff down. In a little bit, we're going to go through a table that organizes all this information. I just want you to get a better visual of what's going on with the graphs. So if our equations are in the form x squared equals 4 times p times y, this is our basic parabola. If it's in this form where x squared is isolated by itself, that implies that our graph is either going to open up or open down. Okay, you can see our focus is going to lie within our parabola. Okay, if you're thinking of this as a bowl, the focus lies within the bowl. Our directrix is going to be opposite of that focus. Same thing over here. If we're looking at the other graph, our focus lies within the parabola and the directrix is on the other side of the focus. These graphs are going to involve similar ideas. It's just now the graphs are going to open to the left or to the right. So these are in the form y squared equals 4 times p times x. We can still see our focus lies within the parabola, directrix on the other side. Focus lies within our parabola, directrix on the other side. So if our equation is in the form y squared isolated by itself, our graph is going to either open to the right or to the left. If it's like the previous slide where x squared is isolated by itself, then the graph is going to open up or open down. Here is a table that organizes a lot of that information we were just talking about, and this is for parabolas with the vertex at the origin, so 0, 0. So this is something I would write down in your notes just to keep everything organized. So we have our two types of equations, x squared equals 4 times p times y. That is going to open up or open down. The focus is going to be at the ordered pair 0, p. The directrix is going to be the line y equals negative p. The axis is going to be the y-axis. The focal length is going to be p, so that's the distance from the vertex to the focus or from the vertex to the directrix. And then the focal width, that is the absolute value of 4 times p. We do not refer to that often. So if you're going to ignore something, ignore the focal width. And then we have the similar information for y squared equals 4 times p times x. That's going to open to the right or to the left. The focus is going to be at the point p comma 0. The directrix is x equals negative p. The axis is going to be the x-axis. The focal length, again, is going to be p. Now that we have all this information organized, we're going to go through an example that requires us to find the equation of a parabola when we're given some of these pieces of information. So the example, find an equation in standard form for the parabola whose directrix is the line x equals 3 and whose focus is the point negative 3, 0. So based on the information in the problem, there's a few things we can determine. First, if we know the directrix is the line x equals 3, it's a vertical line, x equal to some number, that tells me that the standard form of our equation is going to be in the form y squared equals 4 times p times x. If this had been y equals some number for the directrix, then it would have been x squared equals 4 times p times y. So we know we're going to be in this form. Our general equation for the directrix is x equals negative p, and our ordered pair for the focus is p comma 0. So we're given this information, knowing the directrix, this would be the same as x equals the opposite of negative 3. So from that, we know our value of p is going to be negative 3. We can also get that from our focus, because the first ordered pair is the value of p, which is negative 3. So now that we know that p is negative 3, all we have to do is go back and type that into our equation. So our standard form for this parabola is y squared equal to 4 times negative 3 times x, and then we can just simplify that. So we get y squared equal to negative 12 times x. So this is a standard equation for this parabola that has a directrix at x equals to 3 and a focus at the point negative 3, 0. Now we have a table of information for parabolas that are not centered at the origin, so our vertex is going to be the ordered pair hk. So our standard equation x minus h quantity squared equal to 4 times p times the quantity y minus k. This is for parabolas that open up or down. The focus is going to be at h comma k plus p. The directrix is y equals k minus p. Our axis is x equals h, and the focal length p. Then we have the standard equation y minus k quantity squared equal to 4 times p times the quantity x minus h. This is the standard equation for parabolas that open to the right or to the left. The focus is the ordered pair h plus p comma k. The directrix x equals h minus p. The axis y equals k, and the focal length is p. Last example, we want to find the standard form of the equation for the parabola with the vertex at 1, 2 and the focus at 1, negative 2. So some of the information we know in this problem, obviously we're given the vertex and the focus, but when looking at the vertex and the focus, I noticed that my x values are both 1. So from that information, I know the axis must be x equals 1. If those two x coordinates are the same, the axis has to go through the vertex and the focus, so the axis must be x equals 1. We know the vertex is 1, 2. And some information we're going to have to use next is that the focus is the ordered pair h, k plus p. Because I know the axis is x equals 1, it's a vertical line, I know the standard form of my equation is going to be x minus h quantity squared equal to 4 times p times the quantity y minus k. Some of this information we already know. Since we know the vertex, we know our h value is 1 and our k value is 2. Now we need to find our value of p, which is the focal length. And that's where we're going to use the focus. So this expression for our y coordinate, which is k plus p, we can set that equal to negative 2 because we know that's the y coordinate of the focus. I also know my k value is 2 from the vertex. So now we have 2 plus p equal to negative 2. I would isolate p by itself, subtract 2 to the other side. So now I know p is equal to negative 4. Now I just have to plug in all of the information. We have x minus our h value of 1, quantity squared, equal to 4 times our p value is negative 4. And then that's times the quantity y minus 2. Now we just simplify 4 times negative 4. So our final equation is going to be x minus 1 quantity squared equal to negative 16 times the quantity y minus 2. So for this lesson, you need to know the basic definition for a parabola involving the focus and the directrix. You also should have that information from both those tables. The first one where we had a parabola with a vertex at the origin, and then the second one where we had parabolas with a vertex anywhere on the coordinate plane, so at hk. Then also review those two examples. We'll go through some more in class, understanding how to utilize all these different things, the focus, directrix, axis, and using those pieces of information to write the standard equation for the parabola.